Namaste friends, myself SN Khalas, lecturer in Electrical Engineering Department, VPMP Polytechnic, Gandhinagar. Subject name is Microprocessor and Controller Application. GTU subject code is 3350904. Unit name is Programmable Logic Controller and SCADA. Topic name is Programmable Logic Controller PLC. Objectives of this lecture are introduction of PLC, difference between PLC and digital computer, history and development of PLC, difference between relay panel and PLC, simple block diagram of PLC, architecture of PLC, inputs or outputs, programming of PLC, advantages and disadvantages of PLC, application of PLC and types of PLC. Now we see the first point or the first objective of this lecture, introduction of PLC. As we know, Programmable Logic Controller is a digital computer which is employed for automatic control of machines in assembly line of electromechanical process. PLC are designed for multiple input-output compared to the input-output of a computer, and these are designed such that this can work without trouble in industrial environment like excessive temperature, electrical noise, moisture, fumes, vibration, etc. Programmable logic controllers came into existence after the electronics and computers were developed. Programmable logic controller is digital computer which is employed for automatic control of machines in assembly line of electromechanical process. Now we see difference between PLC and digital computer. This is very important question which will be asked in GTU paper, GTU examination. Okay, see, the construction of PLC is rough and it is designed to operate in industrial environment like excessive temperature, humidity, etc. Interfacing of input and output is kept in the controller itself. Its programming can be done easily, right? Now, relay were extensively used in industrial process before the existence of PLC. The difference between the relay panel and PLC are as follow. See, here we explain, here we understand the main difference between relay panel and PLC. This is a one kind of comparison, right? So first comparison between relay panel and PLC is large number of relay are used. In relay panel, large number of relay are used, and in PLC, digital circuit is used in place of relay, right? This is the first comparison. Second one is, in relay panel, more time is required in panel wiring. In PLC, time is saved as no much wiring has to be done. Third point is, in relay panel, reliability is less. Now in PLC, reliability is more. Fourth one is, in relay panel, size required is more, and in PLC, reduced panel size is needed, right? In relay panel, capacity of power supply required is more. In PLC, reduced rating of power supply is required. Okay. Next point, in relay panel, control action is slow. In PLC, control is fast. In relay panel, to make the changes in control, change in wiring has to be done. In PLC, change in control is achieved by changing the program without making the change in connection, right? Next point, in relay panel, flexibility is less. In PLC, flexibility is more, right? In next point, in relay panel, this system is not much used today. In PLC system is extensively used. Okay. Last point, the maintenance is necessary in relay panel. in PLC, no much maintenance is required. Okay. Okay, so this is all about the difference between relay panel and PLC. This comparison will be asked in GTU examination. So as per GTU examination point of view, it is a very important question, right? Okay, the next point is simple block diagram of PLC. As shown in figure, this is a block diagram of PLC, right? In which CPU unit is there, power supply is there, user program, RAM, data RAM, system RAM is there, right? It is called memory, okay, and input output interface is there. In this, there is a one CPU which processes the signal and control all the operations. CPU is the heart of the PLC. There is one memory unit which includes user program RAM, data RAM and system ROM, right? Program is stored in the ROM, data is stored in the RAM. User can make the necessary changes in the program and then it is transferred into the ROM. Input to PLC is given through the limit switch or through sensor or from other source. Input signals is given through the signal interface so that the isolation is achieved between the input and the PLC. Okay. This is the architecture of PLC, right? So in the architecture of PLC, there are so many elements which will be used, right? See, address bus is there, control bus is there, data bus is there, battery, user program RAM, CPU, clock, system ROM, data RAM, input output unit, input output system bus, right? Optocoupler, driver interface. So these are the some elements of PLC, right? Now we see each and every element in detailing. First one is CPU, central processing unit. So CPU is the heart of PLC. Processing and control is achieved through it. Second one is clock. Clock drives the CPU. It is crystal control oscillator which generate square wave. The frequency of clock is between 1 MHz and 8 MHz depending upon the types of crystal used. Timing and synchronizing between different elements is achieved through clock. Data RAM. Data is stored in data RAM. User program RAM. The program is stored temporarily in this. The user can change the program if required. Then the program is transferred into the ROM. Next one is system ROM. Program updated in RAM comes into the ROM. No change in the program can be made in ROM. Program panel. Program is written here. Next point is input output unit. This unit provides interface between PLC and input output devices. Next point is input channel optocoupler buffer. Signal produced by the sensor or limit switch or any other input devices are given to PLC through optocoupler and buffer. Latch driver, interface driver, output channel. Output of PLC comes to the driver interface through the output latch circuit and comes to the output driver stage, and the output signal is available to the actuator. Next point is address bus, control bus, data bus. This buses provides information to different elements of PLC. Okay. Now we see the different terms regarding to the PLC. See, first term is sourcing and syncing. Now see what is sourcing and what is syncing. It is also very important term which will be asked in GTU examination. Okay. See, first one, sourcing and syncing. Terms sourcing and syncing are used to indicate how the DC device is connected with the input or output of PLC. As shown in figure, if the current flow from the input module to the input device, then the input module work as the source. Similarly, as shown in figure, if the currents flow from the output module to the load, the output module work as source. Okay. Similarly, we see if the current flow from the input device to the input module, then the input module work as the sink. And if the currents flow from the load to the output module, then the output module is show or is work as a sink. Okay, so this is all about the sourcing and sinking, right? Now second one is set and reset. Okay, so this term is used for flip-flop, counter, etc. Instead of PLC, in digital circuit, the output of the flip-flop or counter may be either at 0 or at 1 state. If the output is in one state, then the device is said to be the set state, S-E-T, set state, S-T-A-T-E. Okay, and if the output is in 0 state, the device is said to be in the reset state, right? In digital computers, in digital counters, the counter is reset by applying the reset pulse before starting the counting. That means output of all the flip-flops are brought to the reset state, right? So this is all about set and reset. Now next one is latch unlatch. Okay, we see the figure. There is input 1, input 2, and there are 2 outputs, right? This is the latching circuit. In this circuit, in control circuits, many a times it is required that the output is energized by applying the input signal momentarily, and the output should remain in that state when the input becomes 0. To achieve this latching circuit is used. For this, the normally open contacts of the outputs are connected in parallel to the normally open contact of the input. Okay, when input contacts 1 are pressed momentarily, the output is energized, so the normally open contacts of the outputs are closed. Now these contacts are in parallel to the input, so the supply to the output remains continue through these contacts. So even if one input becomes open, the output does not become 0. In order to switch off the output, unlatching input contacts are used. Unlatching contacts are normally closed contacts. By momentarily opening these contacts, the supply to the output is cut off and output becomes off. Latching contacts get open and the unlatching contacts get closed. The output remains 0 until the input 1 is given. Okay, so this is all about the latch and unlatch, right? Now next one is programming of PLC, right? So programs of PLC are written in special application software of personal computer. Okay, then it is downloaded in PLC using direct connection cable or network. This program is stored in RAM with battery backup or other non-volatile flash memory. Single program of PLC replaces thousands of electromagnetic relays. Program is written in standard base programming language. Okay. As per IEC standards, the following 5 types of programming languages are available. First one is FBD, function block diagram. Second one is LD, ladder diagram. Third one is ST, structure text. Fourth one is IL, instruction list. Fifth one is SFC, sequential function chart. All this technology make organization of logical operations, but the basic concept of PLC programming is in the same. However, there is difference in input-output addressing, memory organization, instruction set, etc. So programs for different makes of PLC are not interchangeable. Not only this, but also programs of different models of PLC of the same manufacturer are not directly compatible. Okay, so this is all about the programming of PLC. Now, the advantages and disadvantages of PLC. Okay, so first we see the advantages of PLC. First advantage, flexibility. PLC is very flexible. Second one is reliability. PLC is very reliable. Third one is speed. the speed of PLC is more. Compactness. Fourth one, compactness. So the PLC is very compact in size. Fifth one is reduced maintenance. The maintenance of PLC is very less. Last advantage is expandability. So it is possible to expand the PLC, right, for future work. Okay, now disadvantages. So first disadvantage is initial cost of PLC is high. PLC is high. The initial cost of PLC is high. Okay, second one is special trained staff is required to write and enter the program. Okay, it means a skilled person operates the PLC, not unskilled person. So for the operation of PLC, we require the skilled person. Okay, everyone not operate the PLC. Okay, so this is the disadvantages of PLC. Now types of PLC. Okay, there is three types of PLC. First one is micro PLC or small PLC. Second one is medium PLC, and third one is large PLC. Let us see first one, micro PLC or small PLC. Okay, in such PLC, okay, in micro PLC or small PLC, power supply, CPU, input output module and communication part are mounted on the same chassis. Number of input output port are small. Small PLC are expandable. Many types of PLC are available in the market. In most of the PLC, analog type input output ports are provided. Separate module is required for each signal, okay, like temperature, pressure, etc. When many analog signals are required to be monitored, CPIH, Omron, Siemens S7200, Fuzzy Electronic, SPB, etc. are the example of micro or small PLC. Okay, now we see the second type of PLC, it is medium PLC. So in medium PLC, the CPU module, input output or communication ports are separate. These modules are connected by module connector or backplane connector. It has capacity of 2000 input output ports. Omron CSI, Siemens S7300, etc. are the example of medium PLC. Now third one is large PLC. So large PLC are same in size of medium PLC, but their input output capacity is more and are used for large control system. CVMI, Omron, Siemens S7400 are the example of such type of PLC. It means large PLC. Okay, so this all about the types of PLC. Now next point is selecting a PLC. The following are points to be required to consider in selecting the PLC. First point is cost, right? Second point is serviceability or support. Third point is flexibility or expandability. And fourth point is training and documentation. Okay, let us see the first point, cost. The cost of PLC is more than the relay logic, but the additional cost can be covered in same period of time. It is called the crossover point or the payback. This crossover point should be known. It is advisable to purchase PLC when the number of electromagnetic relays are more than 6 to 8. Cost of installation, maintenance and training are also to be considered while selecting the PLC. Okay, so this is the point which is required to be considered selecting a PLC cost. Now second point is serviceability, okay, or support. It should be serviceability or support. Okay, it should be checked that whether the PLC is of self-diagnosis type or not. It should also be checked that whether it is possible to repair in short time or not. If the supply company is to make replacement of the parts, whether it will be possible to replace the part in short time or not. Okay, now third point is flexibility or expandability. The PLC system should be expandable if the process has to be expanded or some alternation are to be made in future. If the PLC is not expandable, the old PLC has to be replaced by the new one, which will be very costly. Okay, now fourth one is training or documentation. Okay, so it should be assigned while purchasing PLC that whether the training will be required to given the technician or not. If the training is required, whether the expenditure of the training will be borne by the company or not. Okay, documentation means the user manual and software support. This should be included with the hardware. Okay, all the above points are to be considered before the choice is made for PLC. Okay, so this is all about the selecting PLC. Okay, hope you will be get benefit for GTU examination from this lecture. Thank you very much.